Assalamualaikum Dr. Nur Aliza. My name is Reza Krasha binti Rezawan. I'm a part-time master student in computer science. This semester, I'm taking research method in computing, which requires me to come out with a proposal for computing project. My lecturer for this subject is Dr. Afiza binti Ismail and my supervisor is Dr. Zalilah binti Abdul Aziz. In this video, I will walk through my proposal which entitles an ant colony algorithm for solving green vehicle routing problem. My presentation is divided into three sections, which is introduction from chapter 1, literature review from chapter 2, and methodology from chapter 3.
Environmental pollution has become a global issue which brings disaster to the ecosystem of the earth. To prevent this, government has made guidelines as well as providing incentive to encourage the practice of greening the earth. This has caused most of the companies start to use environmentally friendly methods, including for logistic purposes, which increase the problem of optimizing the use of logistic as it involves conflict between economy and the ecology. There are several considerations related to green transportation, which is renewable energy sources, hybrid vehicle, and environmental sustainability. For the global concern, vehicle routing problem has included the green technology into consideration, which is known as green vehicle routing problem. For this, there are more constraints to be taken care in VRP, which leads to more complex optimization problem. There are many options in solving green vehicle routing problems such as genetic algorithm, hybrid evolutionary algorithm, simulated annealing, and many more. One of the famous algorithms that have been recognized worldwide is ant colony optimization. Ant colony optimization is a meta-heuristic technique which mimics the behavior of an ant in searching their food. The study of this behavior has been used for years in solving large number of optimization problems successfully. This algorithm was first applied to the traveling salesman problem and the quadratic assignment problem. Now, let me tell you about the history of vehicle routing problem. Before this, company is using manual routing which only exists in the head of the dispatcher. There are also companies who using geographically information to calculate the distance between customer using Euclidean distance, and some of them using it to find the shortest route algorithm to the computerized network model of the route system. VRP contains some of combinatorial optimization, including the traveling salesman problem and the generalized assignment problem. It was then introduced heuristic problem approaches. Okay, the problem statement is, there are many companies who has begun to find a good strategy in arranging the travel of the vehicle to be used for delivery purposes. Such companies rely on tools to aid informing low-cost tours so as to save money and time resulting from travel to customer location. There are many constraints that need to be taken care of to achieve the objective in using the optimal solution, such as the cost, length, and travel time, which depends on the vehicle type, the freshness of the goods, or even customer priority. To solve this, researchers has come up with an algorithm which concern about how things are delivered from one or more point or place to customer place with a group of drivers and vehicle who will move using the planned route with optimal solution. Next is the list of research questions. First, what are the optimal approach for solving green vehicle routing problem? Second, how ant colony optimization algorithm can help fixing green vehicle routing problem? And the last one is, how will the proposed algorithm affect the result of vehicle routing problem? The objectives of my research is to analyze suitable optimization algorithm to solve green vehicle routing problem, to design and develop an ant colony optimization algorithm, and lastly, to apply the algorithm to green vehicle routing dataset for optimal solution. The research scope for this project is focusing on the green vehicle routing problem. The algorithm will apply to green vehicle routing dataset with size less than 50. Significance of the study is the conceptual study presented in this area may serve as a foundation in green vehicle routing problem, which will benefit the company which involved in logistics. The findings of this research are expected to obtain a good quality algorithm to be used for green vehicle routing problem for the understanding of the researcher. The algorithm that has been suggested in this research can be used by researchers to achieve the best solution in green vehicle solution. The outcome of this project is the optimal algorithm which can solve green vehicle routing problem that can be obtained from this study, a system to prove that the result of this study and the algorithm that have been chosen is true, and a report of the study which describes the study that has been conducted. This chapter will discover information and techniques related to optimization problems, specifically vehicle routing problem. This is my concept map which helps me to navigate the domain I choose. As you can see, first I focus on research regarding optimization and then elaborate more on the vehicle routing problem and formulation. Next, my research is focused on optimization techniques, type of vehicle routing problem, previous work comparison, and summary. In this presentation, I will emphasize on the key point of each topic. This is the topic of optimization, which is known as mathematical programming involving decision making. Most of manufacturing optimization problems are combinatorial and NP hard, which requires solution time increases accordingly with size. The number of possible solutions to the VRP is n factorial. To solve this optimization problem, algorithms need to be constructed in achieving the best result. Optimization has been used comprehensively in various fields such as the aerospace design industry, which to minimize the overall weight of the craft. Transportation model, which helps to identify delivery to the customer by minimizing shipping costs and still maximize company profit, which is also known as VRP. Help in deciding employee scheduling to minimize payroll costs while still considering employee condition. While in industry process area, optimization is needed in deciding which speeds product or flow of the process should be used to give more profit to the company. VRP is one of the combinatorial optimization that is important in transportation, logistics, and distribution. VRP is generalized problem in the simple traveling salesman problem, but consists more complex condition involving much more data. The main challenges is to design the set of optimal route in order to deliver goods for customer. Is for one or more vehicle or transportation to a number of places while satisfying some constraints including vehicle limitation, cost controls, time videos, resources limitation, and vehicle load. Vehicle routing problem is categorized into several types of VRP categories according to the constraint and problem situation that occur. This classification is made to facilitate the specialization of problems made based on the relevant categories and can provide more comprehensive solution. As you can see, this is the type of vehicle routing problem that have been worldwide used. Detail of each vehicle type have been elaborated in my report. This figure summarizes the relation of VRP algorithm. Solution for VRP can be obtained by using exact algorithm or approximate algorithms. Exact algorithm can solve only small-scale problems in three groups: directory search technique, evolutionary algorithm, and integer linear programming. In the other hand, approximate algorithms have been used for large-scale problems with acceptable computation time. This type of algorithm is always being used in real world. Two types of approximate algorithm including classical heuristic and meta-heuristic. There are few major classes in classical heuristic, which are saving algorithm, sequential improvement algorithm, sweep algorithm, Petter algorithm, Fisher and Giacomo two-stage algorithm, and improvement heuristic. Meta-heuristic handles more detailed solutions which are able to produce excellent results. There are two categories in meta-heuristic, which is territorial search and population search. Meta-heuristic of territorial search is tabu search, simulated annealing, greedy randomized adaptive search procedure, variable neighborhood search, and large neighborhood search, while genetic algorithm and N colony optimization are used for population search. For this research, I'm focusing in three famous algorithms, which is simulated annealing, genetic algorithm, and N colony optimization algorithm. Simulated annealing is a meta-heuristic algorithm used to overcome combined optimization. It works by repeatedly improving the initial solution by implementing small local changes until no further improvement can be made or the final decision is met. The concept of simulated annealing is inspired from annealing metal work process, which involves heating and cooling material to alter the change of the structure. It was set with high initial temperature and let it slow the temperature down as the algorithm runs in the suitable temperature, which means ending of the searching. This incremental cooling process allows the searching process becomes able to effectively get closest optimum solution. For N colony optimization, which is known as ACO, the idea of N colony optimization algorithm is to mimic the ants' behavior of walking from the colonies to look for food and return back. In the real world, when ants go out to find food, it wanders randomly and will return to the colony back and leave the path that they have traveled. Others ants who find the path will follow the trail path by earlier ants. Ants have special ways to communicate by using pheromone, which is a chemical substance. When ant chooses path, it will choose path that will have the most pheromones as the optimal path. ACO is meta-heuristic technique that uses artificial ants' behavior in finding food to solve combinatorial optimization problem. The advantage of ant colony optimization over annealing and genetic algorithm is because it adapts with change in real time. Next, genetic algorithm is a local search technique in meta-heuristic solution which is inspired by human biology and guided by fitness level of each individual. In each generation, the population health check is evaluated and the multiple individual who has the most fitness will be selected and the chromosomes is modified to form a new genetic population. The best chromosome generated during the search will carry this genetic. It can be categorized into four categories which are known as representation, reproduction, recombination, and mutation. Based on study that have been conducted, N colony optimization algorithm has successfully been used in most of mathematical problem worldwide, especially in vehicle routing problem. Some of the research have generated new improvement in ACO, which known as improved N colony optimization, which also have been proved successful. There are also hybrid N colony optimization algorithm, where the original ACO algorithm and simulated annealing was hybridized with deterministic local optimization process. This algorithm is known as ACO+. Since the effectiveness of this algorithm, there are still many researchers interested in improving and finding ways to make this algorithm produce the best result. The new type of green vehicle routing is also have not left behind to enjoy the advantage of this algorithm. Study in this field is very interesting for the benefit of universal well-being. This chapter presents the research methodology that have been chosen for this project and the approach that conduct this research. I begin with introduce my research framework. The first phase in my research framework is conceptual understanding. In this phase, the activities that have been conducted is identifying the problem faces by transportation company or agencies that employs a fleet of vehicle to serve customer or other entities located over a wide geographical region. Okay, the deliverables of my activities is report for chapter 1. Okay, next, background study on vehicle routing problem and technique used to solve the problem. Then the activities is reviewing the literature on domain and common technique use. Okay, the deliverables of these activities is report chapter 2. Next, this is the second phase of my research, which is system design. Okay, the objective is to design and develop an end colony optimization algorithm. The activities are, as you can see, first is to identify project setup, which the deliverables are software specification, hardware specification, and tools. Then the activities is to construct the system framework, which the deliverables are pseudocode and of an algorithm and problem formulation. Next, the activities are identify available data set for evaluation, database diagram, ETL, modify data if needed, data relabeling, and last one is test the data. Okay, the deliverables are data preparation and readiness. Okay, next is the documentation, which the deliverables are report for chapter 3, which is methodology. Next is the third phase in my research, which is test and evaluation. The objective is to apply the algorithm to green vehicle routing dataset for optimal solution. Okay, the activities are readiness of the environment, install and setup. The deliverables are the development setup. Okay, next is the activities are develop running program for testing purposes, retrieval data from database, testing the system free from bugs, run calculation for getting the test result. Okay, the deliverables are a system to test algorithm effectiveness. Next, the activities are to test the task based on situation, check for accuracy, collect the data, analyze the data based on case study, evaluate the result, make conclusion based on result, and preparing and writing a document. Okay, the deliverables are test result, recommendation, suggestion, and final report. Next is the technical requirement. To achieve the objective of this project, a proper hardware is required in order to create a runnable project. As you can see, this is the hardware requirement for this project. The operating system that I will be used is Windows 10. The CPU is 8th generation Intel Core. The GPU is NVIDIA GeForce MX 130. The RAM is 8GB dual channel DDR4 and the motherboard is Dell Inc. For the implementation of system development in this project, the specification of software and tools used are as stable. The web server that I've been used will be XAMPP. The database manager is SQL York. The documentation is Microsoft Word. For the IDE, I use Sublime Text and VS Code. For web navigation, I'm using Google Chrome. And for presentation, I'm using Microsoft PowerPoint. Okay, this is the flow chart of end colony optimization with the pseudocode. I will use this as a guide when developing the system to prove that the effectiveness of the algorithm that I use.
That's all for today. Hope my proposal fulfill all the requirements of this research. Thank you.